is nothing but knowledge. So these are 9 facts that have been given. So yesterday we already saw this, that these are the 9 facts which are represented using predicate logic. And what do we have to prove? We had to prove what is known as, was Marcus loyal to Caesar? This is the proof that we have to deduce. Now I told you, in order to prove under logic reasoning, there are typical 2 different types of proof. One is proof by resolution and the other is proof using backward reasoning. So first of all, we will see the simplest of both, that is proof using backward reasoning. And what is this proof? That is, you start with the goal. That's why it is known as proof by backward reasoning. Is this part clear, everybody? That is, we are, oh sorry, you're not able to see the screen. I'm extremely sorry. Okay, PPT not visible because I had not shared it. I'm extremely sorry. I started using it without sharing it. Okay, fine. I hope now it is visible. I'll just quickly go back. See, we are considering an example where we are trying to check out whether I can program my machine to draw inferences. But before I write a program to check whether my machine can draw an inference, how would I do? How would I go about? Usually what happens, you have a knowledge base. A knowledge base comprises of a set of facts or information. The common word that is used is facts. For this particular example, there are 9 different facts that are available with us. Now, if I have to program a machine to do this, what I have to do, I cannot enter the facts as it is. I will use Prolog coding, wherein I will convert these facts into a predicate logic. And yesterday we have already seen this, where how I am converting these facts into predicate logic. So I am having 9 different facts which are represented in 9 different notations of predicate logic. Again, I told you, using predicate logic, we are having 2 different proofs that are available. One is proof using backward reasoning and the other is proof using resolution. Before we see proof using resolution, let's see proof using backward reasoning. And proof using backward reasoning is not why the name is so, because we begin with the goal state. So now, what is that we have to prove? We are given the 9 set of facts. That is nothing but these facts. And looking at these facts, I have to prove whether Marcus was loyal to Caesar. Now, if you see, nowhere in the facts it is listed that Marcus is loyal to Caesar. Nowhere in the facts it's listed Marcus is loyal to Caesar. We have different statements that are there which tell us what is Marcus or who is Marcus, and that tell us who Caesar is. But nowhere there is a fact that states whether Marcus is loyal to Caesar or whether Marcus is hated Caesar. So now, how do I draw the conclusion to it? For this example, I have shown it in the slide. I'll be solving one different example again, where I'll be solving it on the board. So now in this case, was Marcus loyal to Caesar? Since you have to begin with the goal, what do you have to do? You have to first convert this sentence in the representation of predicate logic. So when I have to convert it into a representation of predicate logic, what happens to that representation? Loyal to is a predicate which comprises of Marcus Caesar. But since I am not sure whether Marcus was loyal to Caesar or I'm not sure about this, and basically predicate logic, backward reasoning begins with one basic concept, that is, whenever I begin the proof, I begin it with a negation. So I have the word loyal to Marcus, Caesar, and I negate it. So I begin the proof with a negation. Now, if you look at this, let's go back to the 9 facts that are listed. Here, what is written is use 7 and substitute x and y. What does it mean? That is, I have a fact number 7 where not loyal to is there on the right hand side of the implication, sign. See, this is an implication sign, and on the right hand side I am having not loyal to. So here what am I going to do is this not loyal to Marcus comma Caesar, which is there in fact number 7, I will pick it up, but provided x is replaced with Marcus and y is replaced with Caesar. Now, what is there on the left side of the implication sign? I have person x. Now, person x will become person Marcus. Ruler y will become ruler Caesar because I am replacing x with Marcus and y with Caesar. Try-assassinate x comma y will become try-assassinate Marcus comma Caesar. So, while proving, what I have done, I have begun with the goal. I have negated the goal. Now, I search in my list of facts. Where is a matching fact where I can substitute x and y and use it? So what do I have on the left hand side of the implication sign is all this. Now here what I'm saying is use 4. What does use 4 meaning? In fact 4, that is, this is fact 4. I have a fact ruler Caesar. So what does it mean? That ruler Caesar is a fact which is true. So any fact that is true, I remove it from this AND. Please understand, when you're ANDing, true and true will give you true. That's why ruler within bracket Caesar is a fact which is true. So I remove it. See, I have written here, ruler is a fact, so remove it. I'm using which number fact? Fact number 4. Now I'm left with the residual, that is this. Now what do I have to do? I have to check whether any of this is true. Now here it is saying use 8. Use 8 meaning fact number 8 is try assassinate Marcus comma Caesar. So this is also true. So try assassinate is a fact which is true, so remove it. Now I am left with person Marcus. Now in 9 number fact, person Marcus, I'll replace x with Marcus, where will give me man x. So I'm left with man Marcus. Now if you see that we began with a sentence where we said Marcus is a man. The first sentence itself, man Marcus. Marcus is a man. So what happens is Marcus is a man is true. So this is nil. So when I have reached nil, what does it mean? That the fact not loyal to Marcus comma Caesar is true. That's why I have reached the nil. So I have proved that Marcus was not loyal to Caesar. Are you able to get this? Yes, all of you? Yes, all of you? If you are able to get this, we'll go to a different example which I'll show it using the board. I'll take an unsolved example from the book Rich and Knight. Okay? I will take an unsolved example from the book Rich and Knight. I will read out that example because I will not write the English sentences on the board, but I will write the conversion of those English sentences. Okay? Just give me a minute. I'll just open that particular chapter. You also be ready with your pen and paper because we are going to take up an unsolved example. Okay. Now you can just make a note of this because it's I don't think any of you have this book with you because I'm unable to get the e-book. But what you could do is this is from page number 126. Page number 126. I'll just exit out of presenting the slide because I need to share the board. Okay. Page number 126 of the book Rich and Knight. Okay, this is the book Rich and Knight. Now, this is exercise number 4. Okay, there are 6 facts that have been given for this particular example. And what are the facts that have been given? The first fact, I will read out the English sentence that is there. The first fact that is given is John likes all kinds of food. That is the first fact that has been given. And if I have to represent this in the predicate form, how will I write it? For all x.
Ma'am, screen not clearly visible.
Now is it visible? Yes, okay. So first sentence is John likes all kinds of food. I am not writing the English sentence, I am directly writing the predicate form. So how will I write it? For all x, food x implies likes John, comma, x. So this is my first fact. What is the second fact that is there? Apples are food. So it is very simple. Food, apples. The third fact is chicken is food. So food, chicken. Fourth, anything anyone eats and isn't killed by is food. Anything anyone eats and isn't killed by is food. So for all x, for all y, eats x comma y and not killed by x comma y implies
Blurring.
Abhishek? Abhishek? अभिषेक हे ब्लर का होतं आहे मध्ये मध्ये हां का ब्लर होतंय मला म्हणतात का फॅन बंद करतो तू ते कट होतंय का फॅन बंद कर आता क्लिअर आलाय आधीपेक्षा क्लिअर आहे थोड़ा zoom कर बघू yes आता clear see what is the sentence that is given anything anyone eats and isn't killed by is food so for all x eats x comma y is it clear now I reply it
Yes, ma'am.
and not killed by x comma y implies food y. Now the fifth fact that is there is Bill eats peanuts and is still alive. Bill eats peanuts and is still alive. So this is represented as eats Bill, comma peanuts and can I use this? I'm asking all of you. There is a mistake I have committed in this. Can I use alive? Because what the sentence is? Bill eats peanuts and is still alive is the sentence. Preferably, I would not be using it. Why? Because I have used not killed by meaning alive. So here also I should make use of the same predicate and say Okay. The sixth fact, there are 6 facts listed in this example. It is an unsolved example in the book. Sue eats everything Bill eats. So for all x, okay, eats Bill, comma x implies eats Sue, comma x. So it is as simple as if Bill eats the food apple, that is x is replaced by apple, it implies that Sue will also eat apple. So these are the 6 facts that have been written in predicate form. Now, of course,
Blurry.
see, the blurring is because of the internet thing, but you will be able to see once the internet adjusts itself. The blurring is only for few seconds. It is not permanent blurring. Okay? It's not permanent blurring. I think now it is more clear. Yes? Yes, all of you? I need a response. No? What is no? What is no? No meaning it's not cleared yet. Oh. Abhishek? Abhishek? Are you not able to see anything from this list that I have written? 6 facts. Please somebody switch on the mic and talk because it's going to be very difficult then otherwise for me to solve. See, preparing a PPT for this has become very difficult. You saw the earlier example. I had to literally search for symbols and I had to prepare the presentation. That is not readily available. Okay. So I felt one example, I prepared a presentation, and the second example solution, that is this solution, I felt we will make use of the board. Is it visible now? Yes. Please switch on the mic and at least answer.
No, ma'am.
What is not visible? You are not able to read the alphabets?
It has blurred.
You cannot read the words.
Because we have not moved anything.
Ma'am, can you use black pen?
Black pen has ran out of ink. 1 minute.
Ma'am, black pen is more visible.
Actually, my black pen has ran out of ink. Okay, now anyhow I am using somebody else's blue pen. Ideally, I do not use anybody else's pens at the moment because of the pandemic. But since it is not visible to you,
Ma'am, now visible.
all 6 facts are visible.
Yes, ma'am.
For all x, food x likes John, x. Food apples is the second fact. Third is food chicken is the third predicate. Fourth, for all x, for all y, eats x, y and not killed by x, y implies food y. Fifth fact, eats Bill, peanuts and not killed by Bill. 1 minute. It's not only not killed by Bill, it is not killed by, Bill is not killed by what? By peanuts. Because of the blurring, I wrote half only. And the sixth is, because what was the sentence there? The fifth fact was, Bill eats peanuts and is still alive. So we have to write Bill eats peanuts and is still alive. So eats Bill, peanuts and not killed by Bill, peanuts. So these are the 6 facts that are there. What has been asked to prove? You please write this down in your book. Those of you who are noting down and are seriously attending the lecture. There are 5-6 questions for the same example. We are solving one example here using backward chaining. What has been asked? Prove that John likes peanuts using backward chaining. So what we have to prove? We have to prove John likes peanuts. Okay. Now, I don't want to rub the board actually. What I will do, I will rub this numbering. We already know there are 6 facts, and I'll shift the board slightly so that you will be able to see the edge of the board also. So what have we been asked to prove? John likes peanuts. So how will I write this? John likes peanuts, I will write it as likes. Is this visible, all of you? Yes, is it visible? Yes. Okay, likes John, comma, peanuts is what we have to prove. We have to prove this. Likes John, comma, peanuts. But what did I tell you is, we do not know whether John likes peanuts or not. Correct? We do not know whether John likes peanuts or not. Now, if you see, where is this particular thing going to map? It is going to map to your fact number 1. How is it going to map? If I substitute X with peanuts. And what am I left with? On the left hand side is food, peanuts. Correct? Okay. Now, if you see, this is 1, 2, 3, 4. Fact number 4. I am having here food Y on the right hand side of the implication sign. So, if I substitute, if I take fact number 4 and if I substitute Y with peanuts, what am I left with? I am left with eats X comma peanuts and not killed by X comma peanuts. So I have selected fact number 4 that is there. Okay. Now, when I select fact number 4, you see this eats X comma peanuts and not killed by X comma peanuts. If you see the list of facts, this fact number 5 is having both these sentences, correct? Is having both these sentences, provided I replace X with Bill. So I will use fact number 5, but I will substitute X with Bill. Okay, and then what do I have? Both of them are true because there is no implication sign in this. So what do I have? I get a name. Okay. Have you understood this? Have you understood this? I am expecting a question from all of you.
At first question you started with negation, this time not.
Ah, correct, correct. What is that? What is that?
You said always we first start with
I
negation.
deliberately did not do that. What did I tell you? Backward reasoning begins with a negation sign. That is, when you were asked prove, what was the proof asked? John likes peanuts. This was the proof asked. So there are two answers to this. One is whether John likes peanuts or he does not like peanuts. And I told you that you have to begin proof by backward reasoning with a negation. So when I say negation, you will first write likes John, comma, peanuts. But when you begin the proof, you begin with a negation. Now you tell me, if I begin this with a negation, what is going to happen? What is going to happen? Yes? Yes? Yes, all of you? What does this mean? If I've got a nil here, what does it mean? John does not like peanuts is true. You had to prove whether John likes peanuts. The answer to that question is he does not like peanuts. Is this clear? Is this clear? Yes? We will move on further because this is just one small part of the proving. We need to go ahead. Can anybody tell me the time? Because while solving the problem, we don't come to know the time. Is our lecture time over? Is our lecture time over? Because I wanted to show you another example, which is a very big example from your book, Rich and Knight. It is a similar example, but see, this is the example. I have not written the English sentences because we are going to discuss actually for this example proof by resolution. And proof by resolution, I'll just quickly wind up and tell you because next week we have to see this. Proof by resolution involves a different technique. What does it involve? When I'm given English sentences and when I convert those English sentences into predicate form, that predicate form of representation is known as well-formed formulas. And if I have to prove using proof by resolution, see, this is the proof by resolution. I cannot make use of well-formed formulas. What we were seeing today in backward reasoning was well-formed formulas. We have to convert those well-formed formulas into canonical normal form. And in order to convert to canonical normal form, there are rules, I'll call them. I'll not call them steps, because when you use the word steps, it is like I'm using step 1 first, then I'm using step 2 first. It doesn't work that way. These are rules that are used for conversion to canonical normal form. I'll just quickly tell you that when it is man Marcus, there is no rule applied to it when it is simple predicate. But whenever there is an implication sign, like in this case, all Romans, all Pompeians were Romans is the English sentence. So there is an implication sign, and for that implication sign, I apply rule number 1. That is, when I remove this implication sign, what happens to the predicates? That is, whatever is on the left hand side of the implication sign gets negated, and an or symbol comes in between, and on the right hand side of the implication sign, you get the remaining predicate. So when we are using proof by resolution, we apply one of the 9 rules in converting the predicate form or the well-formed formula form into canonical normal form. Why is it known as canonical normal form? Please understand this. We want all disjuncts of predicates. What do I mean by disjuncts of predicate? You see here, each predicate is separated by an or sign. Why is it separated by an or sign? It is as simple as this is true or the other one is true. There is no and sign in between them. That's why it is known as canonical normal form. So in the next class, we will see this canonical normal form and proof by resolution. And simultaneously, we will be seeing the unification algorithm. Under lab practice 1, you are supposed to implement this unification algorithm. I know it is a little heavy dosage, especially when we are teaching in the online mode, but I'm sorry, you have to cope with this, and I have to try and simplify it and tell you. That's it. Okay, so we'll stop here for today, and next week we will begin with the proof by resolution. Meanwhile, if you are able to get hold of the Rich and Might book, on page number 126 and 127, there are a number of exercises, unsolved exercises which are there. So you can just go through it, and then if time permits, we will solve those exercises. Okay then, till next week. I'll stop my lecture here at the moment.